I like this last lesson. In fact, I think it's one of my favorites because it brings together all of our congruence conversations and gives us really the difference between postulates and theorems. So hang with me for just a second and go back to the very beginning of your packet. Euclid gave us these three postulates. If you think about it and understand the difference between a postulate and a theorem, a postulate is our given. That's what Euclid tells us. Euclid's like, hey, you need to prove things are congruent. Here's the rules. In order for two things to be exactly congruent, they need to be the same size, same shape. You're like, got it. So then initially we're like, by definition of congruence, that means that every side and every angle has to be identical, and then I can make a congruent statement matching up your vertices. Euclid's like, woo, you see what I got for you. I'm going to cut your work in half with triangles. I'm going to say all you need are 3 pieces of information, not 6. You used to need 3 sides and 3 angles. No, 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 no. If you have these combinations here, you can guarantee congruence. 3 sides match 3 sides, you're good to go. 2 sides and the included angle, you're good to go. 2 angles and the included side, you're good to go. So we don't have to prove these because they're postulates. They're already given to us and we can use them. The tricky part is being able to identify what is given to us and what we know through other methods. Our last lesson, Euclid brings about some new conversations. And he's like, okay, so stay with me, Hal. You know how we talked about the third angle theorem and we proved that? We can use that shortcut to give us another shortcut. We can say if you have 2 angles and a side, even if the side is not included in those angles, you still have congruence. Because the third angle theorem guarantees you have whatever angle you're missing. So instead of going around and proving that third angle theorem, let's just say you can have angle, angle, side. So instead of the 3 postulates alone, now we have a theorem. And the theorems are things that we can prove. Once we prove it, we can use it. We proved it. Good to go. So we can go ahead and use our third angle theorem every single time. The next conversation is, okay, now that I have 3 angles, can I use 3 angles? How come I can have a side, 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 but not an angle, angle, angle? And you're like, nay, nay, don't get confused. Make sure you tell the difference between angles in a triangle and sides in a triangle. Because 3 angles is not a postulate. Because you can't guarantee whether you're looking at a bigger or a smaller triangle. Angle, angle, angle is a relationship, but not about congruence. And those of you that did the delta math, you saw that. You saw that you could declare that as a relationship, but not necessarily one that would guarantee congruence. So then the really cool part is we can have this conversation here where we can talk about, all right, well, how come I can't have an angle and 2 sides? And you're like, you can if it's a right triangle. But you can't if you have the possibility of that triangle being either acute or obtuse. So we can look at this side C and we can say, hey, wait a minute. With these 3 facts, this side, this angle, and this side, I can make 2 very different triangles. So back to that unit 1 conversation about if it's not true all the time, then we say it's false. If we can't prove as a statement is true every single time, 1 counterexample blows it. That's what happens here. If I can make 2 triangles, I can't guarantee congruence. So we joke about no cursing in geometry. They call it the side-side angle. We call it the angle side-side. Like, oh, that's the ass postulate. We're not going to get fooled by the ass postulate. No asses, no cursing in geometry. Until we get to this one, you're like, except for this one. And the reason why we can use this one, we can come up with two justifications. One justification, hypotenuse leg infers right triangles. When you read hypotenuse, you read right angle. When you see a right angle, you know it's hypotenuse. You need to know that those are like two besties. Those are two besties that always exist together. If you have a right angle, you have a hypotenuse. If you have a hypotenuse, you have a right angle. You can't have a hypotenuse without a right angle. You can't have a right angle without a hypotenuse. Got it? So as soon as I see this hypotenuse leg, I know I have a right triangle, which means I can do Pythagoras. Now logic with me on this one. There's two ways to consider why HL is okay. If I have A and C, and I put it through the Pythagorean theorem, aren't I going to get the same answer for B? So the Pythagorean theorem justifies hypotenuse leg. I'll say that one more time. If I have a leg, and we'll call it A, and I have a hypotenuse, we'll call it C, I can use Pythagoras. So if I put this value into the Pythagorean theorem, and I put this value into the Pythagorean theorem, when I go to solve for B, aren't I going to get the same answer both times? Yeah. So the triangles are guaranteed to be congruent. So the Pythagorean theorem lets us use this version of but we have to make sure that it is a hypotenuse, and we have to make sure it's a right angle. Now, interestingly enough, a couple of people were doing delta math last time, and when you were doing delta math, you were confused because you got one wrong. And I want you to tell me what this person was doing wrong. They were doing delta math, and they ended up with this triangle here, and they ended up with this triangle here, and they were told that they were both right triangles. And they saw that this side was congruent to this side, and they saw that this side was congruent to this side, and they went ahead and they said, yes, they can be proven congruent, and then they went ahead and said it was because of the hypotenuse leg. So all the hands in the air are the people that got this question. Turn to your partner and tell them what the answer is. Talk about it. Did you get tricked by this one? No. Probably. No. Who said no? You're smarter than that. There you go. This is not hypotenuse leg, and because it's side, angle, side. And it's funny, I think it's obvious that we're going side, angle, side. And I had a kid last year that's like, it's confusing me. We have these names. I get side, angle, side. I get that's SAS. But I don't understand what the difference is. So they weren't connecting that they were naming a side and the included angle and the side. So when I say side, angle, side, this is this side, the included angle, and this side. Typically when I take the time to do that, there's at least one kid that goes, oh, because they haven't made that connection yet. Look your partner in the eye and ask them, have you made that connection? All right. Take a look at your homework, please. Have it out. Practice number 1 asks you, how are the triangles congruent? So when we look at A and B and C, one of them you would have said they're not congruent. Which one? A, B, or C? B. That's right. B is not congruent because that is an angle, angle, angle. Now in delta math, you would have said that these are related by angle, 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 but you would have also said that they are then not congruent. Caroline was working on the delta math, and she came up with ones that were not congruent, and she clicked not congruent, and it didn't give her the flow proof. And she's like, oh my gosh, but delta math is busted. What did you figure out?
That after it's not congruent, you have to ignore.
Yeah, those are like the easy ones. It's almost like, do you remember last unit when you got 3 sides of a triangle that didn't make a triangle? So if they do make a triangle, you have to say, is it acute, right, or obtuse? But when you caught ones that didn't make a triangle, you're like, it's not a triangle, right? I don't have to do that Pythagorean converse. Same story. If you get this on Delta Math where it's not a triangle, you can be like, skip an arrow on that work. It's kind of nice. Isn't it just the little things that make you go, hee, I don't have to do that work anymore. Is this hypotenuse leg? Why?
It's 2 sides and then
Because I have 2 sides, I have an angle, that angle's a right angle. Once I see a right angle, I have a hypotenuse, so this is hypotenuse leg. All right, looking at D, E, and F. I see angle, angle, side. I see side, 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 and I see side, angle, side. We all good with that? Looking at G and H and I, side, angle, side, not hypotenuse leg. Are we good on that? And then we get into this whole reflexive property with shared. If you struggle with the triangles that are flipped or turned or rotated or overlapping, take the time to either sketch them separately. Sometimes it helps them to put them in the same orientation, and then you can see which sides are matching up. This one's going to be angle, angle, side. You okay with that? Angle, angle, side? Say yes? Okay. And then this one, we cannot prove congruent because this is our ask postulate. We're okay with that? Actually, I shouldn't say ask postulate. It's not a postulate. It's an ask relationship. And then I shouldn't curse in geometry, so sorry. You're like, my tender ears. I've never heard such language. Here we go. Write a paragraph proof to prove the triangle is congruent. Would you please turn to your partner and share your proof? Go. And somebody on Delta Math and I were toying with this, and it's a question of, is this given, or do I have to do some geometry that those angles are congruent? And on Delta Math, they made you state that they were right triangles. Did anybody get that proof? Yeah. On Delta Math, they make you take the time to say that you can't use hypotenuse leg until you state you're dealing with right triangles, right? But what about these being congruent? Because I'm working my way towards angle, angle, side congruence here. I see I'm given 2 angles, and I know that I have 2 right angles, and I have this side. I'm going to say that you're given that they're right angles, and all right angles are congruent is going to be your next sentence. Does that make sense?
Yeah.
So, yes, you're given information, but you have to tell the difference between, what does that symbol mean? That symbol means it's a right angle. What do we know about right angles? All right angles are congruent. Are you with me on that? Okay. So Corey got you a Smartie that filled you up, so you get candy today. Make sure when I give you your work time, somebody's like, psst. Okay? Go ahead.
Is that also work for alternate interior angles that are?
Yeah, so if you get 2 angles that are congruent because they're alternate interior angles, it wasn't given to you that they were congruent. That's your big geometry brain knowing, parallel lines, transversal, alternate interior angles are congruent. Okay? So it is, we definitely need to tell the difference between what is given to us and what is not. You okay with that? All right, turn the page. I love these questions. Your test has 3 of these that look very much like this, but with different questions. So this is the number 1 thing you need to make sure you understand how to do. Because then there's 0 arguments. Because we ask you, name what additional corresponding parts need to be to prove the triangles are congruent. But the most important thing is you need to know that they're congruent by what I say. So if I'm looking at these 2 triangles, I do not have enough information to prove that they're congruent. That's true. Yet, they're asking, what next information do you need? I have 2 angles. Now your choice is, if I'm doing angle, angle, side, you could say this side is congruent to that side, and that would be a good answer. You can say that this side is congruent to this side, and that would be a good answer. Are you allowed to say that this side is congruent to that side? No. Do you see why? Would that side make those triangles congruent? Yes. But it would be angle, side, angle. Is that what they asked me for?
No.
So what you need to do is make sure that even though there may be more than one answer, that you need to be intentional about what they asked you to do. Would you please take a minute and carefully check your work with mine on the key to make sure that your work is correct? On your mark, get set, go. You do not have to list all of the possibilities, you just have to list one. I think on the key, I listed all of them because inevitably, if I list one, someone's like, well, would this work too? That's why I say either those two things would work. All right. The next thing is we absolutely want you marking your diagram. So I think on the directions in the test, we say mark the diagram and list. So get in the habit of talking to your diagram every time. For HL, there's only one choice. You have to pick the hypotenuse. Side angle side, there's only one choice. You have to pick both of these sides. When we look down here, oh, and on the test, we give you a blank to write a congruent statement. So we give you that blank to make that happen. All right, Jennifer, remind me, what was your question on?
On the answer key, it says by LA.
Yeah. Yeah, I don't know why it did that, but it looks like we changed it because you guys have, so this is an older version. So when we copied it from something, like when we pinched this graphic, I think that was from whatever we did, but you can tell that we whited that out and put what we wanted instead. So don't worry about that LA, because I don't know what leg angle is. We changed it. Anything else that you need conversations with or help with? Really get in the habit of marking your diagrams. All right, let's talk about this proof down here. Given that AB is congruent to AD, everybody hold your partner accountable. Make them show you that they talked to their diagram. Peek at their paper, say, show me. All right, when you go through this proof, step one, read it. Read the directions. Step two, talk to your diagram. Put the markings on. Step three, come up with something else that you know is true. Let's see, well, what do I see? What do I know? What do I need? I see that I have that given, but I know they're reflexive property. I know I'm looking at right triangles. So I know I'm looking at hypotenuse leg. My number one tip is, if you want to, skip ahead. Now, pretty much I give you the right amount of lines unless you decide to do something a little crazy. But if you know that you're going to be working towards hypotenuse leg, guarantee the proof that they give you is going to be in corresponding order. So you can absolutely jump ahead mentally and know that, okay, I know I'm doing hypotenuse leg, how am I going to get there? Caroline, what's on your mind?
So in the proof, I put reflexive property first in the second slide, and then I put all angles are congruent. Does that matter?
Doesn't matter. So it doesn't matter. So if we were doing a flow proof, Caroline, you'd put those two things on the same level and they would both add to this. So that's why I love that delta math with the flow proof. It kind of lets you have your pasta water boiling and your tomato sauce and, you know what I mean? You got all that thing happen, all those things lead to one conclusion. So whether you reverse that order or not of 2 and 3, it doesn't matter. Questions on the proof? Okay, for those of you that are doing the proofs, for those of you who are reading, looking, thinking, what do I see, what do I know, what do I need, are they getting easier for you? Yeah. They really are, because putting your brain through that geometry thinking definitely matters. All right, let's move on to the next homework. Again, given that R is the midpoint, and this is my favorite conversation, you are so smart now. Because if you know R is the midpoint, that is what you see, but what you know then is that those two segments are then congruent. What do you see, what do you know, what do you need? I know R is the midpoint, and they just told me that these two angles are congruent, and I have Q and S are right angles. So I'm set up for success right away because I'm looking at the picture. Which postulate or theorem are you going to use for congruence? Say that loud, Audrey.
Angle side angle.
Absolutely, angle side angle. So when you fill in your statements, you have your given. You know that QR, the distance from Q to R is the same as the distance from R to S by the definition of midpoint. How about those numberings? Don't you love it when Word takes over and numbers things? Did we fix it on your paper or is it square too? Yeah. At least it's in order from least to greatest, right? Not really on the justifications. So much for that, right? Definition midpoint, all right angles are congruent, and then we have our congruent triangles by angle side angle. There will be kids in my classes that will see the right angle and do HL. They're like, I saw the right angle. You said every time there's a right angle, it's HL. I'm like, no, it didn't. No, it didn't. They said, if you see a right angle, check for HL. But you need a hypotenuse and a leg. Do we have a hypotenuse and a leg?
No.
So it can't be HL. Angle side angle will do it for you. All right, let's scoot down here. Are the triangles congruent? Do me a favor, check your 6 with my key and you mark a 6. Go.
Okay.
The only one that I said wasn't was E. Do we agree? Yeah. So we can still relate it by angle side, but that doesn't guarantee congruence. E is a little tricky, and we want to make sure that you understand those congruence markings. And if you need to redraw one triangle in the same orientation so you can match up corresponding sides, take the time to do that. But, oh, I don't think that's right. Hold on a minute. Hold on a minute. No, wait a minute. Shh. That's a smarty for sure. That looks like hypotenuse leg to me, right?
Yeah.
We like that better. All right, sometimes having this drawing without a picture puts it on you to be able to draw the pictures and match up corresponding vertices and information. So suppose the angles of ABC are congruent to the corresponding sides of triangle DEF such that A and D correspond, B and E, C and F. Can you conclude that the two triangles are congruent, yes or no?
No.
What do you need?
You need a side.
At least one. Just one side is all we need. All right, next up. Suppose the two triangles are right triangles, and we have those corresponding sides. Can you conclude that two triangles are congruent, yes or no?
Yes.
Because, yeah. And it's interesting, when we talk about, we don't know. The truth is, if I draw these two right triangles, and I name this one GHI, and if this is G, this one is J, and this one is K, and this one is L. Notice that they told us that GH and JK were congruent, and HI and KL were congruent. Can you conclude that they're congruent? Yes, absolutely. But I don't know if it's HL or side angle side. How come? Why don't I know?
because you could draw it like a different way where K is on the right angle.
Yeah.
Different order.
Yeah. Nobody said that G and H were the right angles. They told me it's a right triangle, so I have at least one of them. I know it's a right triangle, so I know I have one of them. But I don't know which one.
So was it no?
Can I prove they're congruent? Yes. By which postulate? Either it's going to be hypotenuse leg or side angle side. Until somebody gives me more information of which one's the right angle, I can't say whether I have two legs. Because when I drew it this way, this is my right angle. G and J were my right angles. But what's interesting is if I had drawn the same two triangles, but instead of choosing G for here, what if I put G and J here? Then when I talk about what sides are congruent, it's these two, right? Congruent to these two. And I could rotate it one more time. Nobody told me which one was the right angle. So it could be hypotenuse leg. There's two instances where it's hypotenuse leg and one instance where it's side angle side. So we'd need to know that. All right, are the triangles congruent? If yes, write a congruent statement to justify your answer. Do me a favor and check very, very, very carefully that our congruent statements match. You want to check. Ooh, did I not write congruent statements on this one?
You did.
Oh, good. Do me a favor and check and make sure that the congruent statements match up. That you got your I don't think I wrote congruent statements.
Oh, you did. No, there's not.
You wrote if the, like what they
Yeah, there's
were,
not.
but not like a congruent statement.
Right, I wrote a justification, but when they ask me to write a congruent statement,
They didn't.
are they congruent? Yes. Actually, these ones are no. Right? Are they congruent? Yes, because I have vertical angles here, right? The congruent statement is triangle TNS is congruent to triangle. If I started with T, I need to start with UHS. That's a congruent statement. And I didn't put the congruent statements on the key. Would you turn to your partner and agree on your congruent statements? Talk about it. Go. So let me tell you something. Can we wait till we get there? Is it about A, B, or C? Okay, hold on just a minute. Okay, so when I used to teach this before the times of Delta Math, we used to not let kids write angle, 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 or angle, side, side, because they are not congruent postulates. Are you with me on that? Then Delta Math comes along and it asks you how are they related. So as soon as you can say that these are not guaranteed because of this, we have to be really, 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 really careful about making sure that everybody knows whether they are congruent or not. Because without this word no, if you wrote this down, I would assume that you think yes and that's the reason. And do you understand why that's wrong? So when we ask you, are the triangles congruent, it is imperative that you answer yes or no. Because Delta Math has us relating them and using angle, 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 and using side, side, angle, or angle, side, side. So if we're going to write the relationships between the triangles, we need a yes or no. Look your partner in the eye and say, write yes or no. The question is, are the angles congruent? Your answer is yes or no. Are they congruent, yes or no? If you do not have enough information, the answer is no. Until somebody gives you more information. So we have a no here. Now, when I write a congruent statement, that implies yes. Because this is a way of saying yes. If you're asked to write a congruent statement, this says yes. Yes by angle, angle, side, these triangles are congruent. yes, by angle, angle, side, these triangles are congruent. Here I have angle, angle, side again, yes, by angle, angle, side. And here I have two lines that are parallel, alternate interior angles, which is going to give me angle, side, angle. Now I saw some hands raised about this one. Is this what you wanted to talk to me about, Clark?
No, it has a congruence marking for DR and CA, so
Yes.
can it be SAS instead of ASA?
Oh, absolutely.
Okay.
Yeah, I got it wrong. That's a smartie. Because I don't have two angles, I only have one. So that is definitely, you are correct. It's side, angle, side. So I owe you one. And F, we're good on no, even though they are related by angle, side, side. Decide whether enough information is given to prove the triangles are congruent. If there is enough information, state the congruence postulate. Why do you think so many people get A wrong? Why do you think so many people get A wrong? What do you think? Ellen, what do you think?
Because angles on it too, see what they do vertical angles.
Do you remember your Unit 4 test? A lot of you got this one wrong because you assumed that 33-degree angle was vertical and it wasn't. Alex is nodding his head. He's like, yeah, I think I made that mistake. Anybody else make that mistake? Where you thought that they were vertical, but it was the two angles that were like this, right? Can you picture it in your head? I think it had, the test had like two triangles that were like this, and this was 33 degrees, and you all put this as 33 degrees too. And it was actually this one, oops, it was, hold on. This one that was 33 degrees, right? So we need to be really careful about vertical angles. Vertical angles happen when two straight lines intersect in those opposite angles. So here, 1 and 2 are not vertical angles. We do not have enough information. That's not how you spell information, to prove that they're congruent. When we look at B, absolutely we do, because we have that reflexive property that gives us our third side. Are we good on that? Excellent. Would you please page back through those 4 pages of homework and ask your partner, which of these did you think was the trickiest? Turn and talk about it. Go. So much of what we do in geometry is there's two planes of what we're talking about in geometry. We're teaching you how to think and be a logical problem solver and to build a solid argument, and we're doing it through shapes. So a lot of what we do, the understanding about the shapes and whatnot, fine. But this lesson here is where we can use our congruent triangles to give us information that we need. So CPCTC stands for corresponding parts of congruent triangles are congruent. And this is why we're proving triangles congruent. So if you woke up in the morning and you're thinking, why do we care? Because I'm sure you do that. You wake up in the morning, you're like, yay, geometry. First thing in the morning, here we go. Ugh, congruent triangles. Who cares about congruent triangles? Why do you care about congruent triangles? This is why. Because if I can prove that the triangles are congruent, do you remember I said Euclid cut our work in half? We used to need 3 sides and 3 angles. And then he's like, no, you can do that with just 3 parts. Either just 3 sides, or 2 sides include an angle, or triangles include a side, or triangles on the other side, or the hypotenuse leg. Because once I use those 3 values to get my triangles congruent, I automatically know the 3 that I didn't know are also congruent. I'm given the other 3 as a present. So what we know now is that if I can prove those 2 triangles are congruent, then corresponding parts of congruent triangles are congruent. And we shorten this by calling it CPCTC. So CPCTC says that if you can prove two triangles are congruent, then you automatically get the other three pieces of information that you didn't know before. Now you're going to have to be very careful because you're going to have to be very mindful about what do I know before I prove them congruent and what am I getting as a result of them being congruent. So Bridger asked me a great question. He's like, I have these two sides, doesn't that mean I automatically get the third side? Not yet. If you prove the triangles are congruent, then yes, you can have that third side. But you can't get that third side without the triangles being congruent. I think the example you showed me, the ones, they weren't congruent, right? So you couldn't say it. All right, let's take a look at this first one. I know that triangle ABC is congruent to triangle DEF. Got it. When I look at this, I know that I have these congruent corresponding parts. I know that A and D are congruent because I'm given that through the diagram. I know that C and F are congruent. I'm given that in the diagram. I know that segments BC and EF are congruent. I'm given that in the diagram. I know that by angle, angle, side, these two triangles are congruent. Once I say that they're congruent, CPCTC gives me all of the stuff that I didn't have. It's like I have the magic code to the lock that springs open everything else. All right, let's take a look at example 2. If I'm looking at triangle FTG, I know right away just from looking at it, it's going to be congruent to triangle RTS. So F and R correspond, my T's correspond, and my G and S. I have these two angles congruent to each other. I have these two sides congruent to each other, and I have these two sides congruent to each other. So I'm given in my diagram that segment FT is congruent to segment RT. I'm given segment GT is congruent to segment ST. And I can't name this angle T, right? I gotta do the 3 letters, right? So I know that angle FTG is congruent to angle RTS. Those are the 3 pieces of information that were given to me. Because of that, I know that the triangles are congruent by side, angle, side. Are we all okay with that? Be mindful of the difference between a congruent statement, which is the top part. Here's my congruent statement. Here's my congruence justification. And here's my given. Turn to your partner and talk about, because of CPCTC, list all the things that you now know. Go. So it's funny, I think I just heard Jasmine say, oh, you just talk about the other stuff.
Yeah.
Was it you that said that?
Yeah, you just talk about the stuff that doesn't have any margins on it.
Yeah. So now you get the other 3 pieces of information. So whatever else you haven't marked up with, now you've got. So in this lesson, we're going to put you into proving things, and a lot of times you end up with overlapping triangles. And we gave you a bunch of examples of diagrams that have overlapping triangles. And if you have a pen of another color, this is a good time to have it out. If you don't, you can grab one of my colored pencils. But it's important that you see a bunch of different triangles in these pictures. do you see the fact that we could be talking about these two triangles? Maybe I should have done that in green. Then it'll show up better. When you're dealing with these diagrams of triangles, it might be easier for you to either draw them separately or highlight them with different colors. When you're looking at these triangles, these overlapping sides, and it's interesting because you get shared sides a lot. So you can see there that TV is congruent to itself when we look at that. But what's definitely confusing is at these angles, are you looking at the right angle or are you looking at these smaller angle measures that are here for each of those triangles? These pictures here give you 6 different triangles that you could be talking about. Whether you're talking about these two isosceles triangles, obtuse triangles that are above and below, or these two triangles that are left-right, or you might be talking about these triangles here. So we have to be careful when we read our given to make sure that we're not assuming that they're talking about triangles, because each diagram comes with a whole host of different options. In this diagram, whether you're talking about these two little triangles or these overlapping triangles, is always an interesting conversation. A diagram that looks like this is particularly tricky because not only do I have these overlapping triangles, but I have these left-right triangles that are congruent, but these up-down triangles that are not. The next thing that I want you to make sure that you're looking at in these proofs is a conversation about whether or not you are given any isosceles situations. The isosceles base angle theorem will come back and bite you at least 1 or 2 times in the next couple weeks, because you'll miss that certain triangles are isosceles. For example, if you are given that these two sides of this triangle are congruent, do you now know that these two base angles are congruent? So even though the green and the blue triangles are not isosceles, the whole picture, the big triangle, is. And you just got a set of congruent angles. Do you see it? Yes. Right? So if you're told that the distance from M to N is the same as the distance from M to Q, that gives you one set of corresponding sides, but do you now see that these angles are also congruent because of the isosceles base angle theorem? Do you see that this little baby isosceles triangle is living inside of those two overlapping right triangles? So if somebody told you that that little triangle was isosceles, it gives you a second angle. Do you see the angle that it gives you? This angle here of that triangle. Beware of the isosceles triangle. Because if you have two sides of an isosceles triangle that are congruent, then you have opposite base angles are congruent. And those isosceles triangles are hidden everywhere you look. So the fact that on each of these diagrams we have two things that make things tricky overlapping triangles, that makes it hard. But the isosceles, that also makes it hard. Can you see them? Turn the page. In this lesson, we're going to have a number of different proofs that we want you to do. You cannot do a proof without practicing how to do a proof. You have to train your brain how to think. Would you and your partner please read the given, mark the diagram, and talk about how you want to go about doing this? And mark it, set, talk. Go. Alright, now that you've had a minute to think and talk about it, come back. So let's, step one, we're going to read. Okay, given those two sides are congruent, I'm going to look at what I'm proving. Okay, so here I go. I'm given that the distance from S to D is the same as ST. So in these overlapping triangles, sometimes it's hard to be able to mark what I'm talking about with sides being congruent. So when I mark those two sides are congruent, I want to make sure I remind myself I'm talking about the whole side is congruent to itself. Okay. Then I know that CS is congruent to DT. So that's a little bit easier for me to see. If you need to draw this triangle and separate it out, please go ahead and do that if that's easier for you. The problem with drawing these two triangles separately and pulling them out is you're absolutely going to get a good picture of these are congruent sides and these are congruent sides, but you might miss the fact that you know that, what?
Because the property SC is congruent to
Those are a shared side. So if you sketch them separately, you might miss that shared side. So I've sketched them, I've looked at my diagrams. Now I can make all kinds of statements from this about angles and vertical angles or whatever, but I want to make sure that I just talk about what I need. You're going to find yourself in a situation where you have too much information sometimes. Now let's talk about what I'm trying to prove. I need to prove that angle SCT. So when I look at SCT, here it is congruent to TDS. And here's the most important thing that you need to do. You need to come up with some notation so that you don't mistake what you're being asked to prove as information. Are those congruent? Yes, they are. Do I know they're congruent? Not yet, because I haven't proven it. It's not a part of my given. You okay with that? Mm-hmm. All right, so when I talk about my given, the first thing that I'm given is the fact that segment SD is congruent to segment TC, and that segment CS is congruent to segment DT, and that's my given. My next thing that I'm going to do is use my reflexive property to get that third side. Now be careful here, because once I say this is segment ST, I have to list things in corresponding order. And do you see that when this triangle is flipped, that my ST becomes my TS? Do you see that order? That is my reflexive property of congruence. Somebody the other day in yesterday's class goes, what is that? They're like, I remember it, but I don't know what it says. The reflexive property of congruence says that something is congruent to itself. It doesn't have to be a mirror image. It only is a mirror image if the shapes are flipped or rotated. It's almost like your reflection. Think about looking in a mirror and seeing your reflection. Your reflexive property says that you are you. You look in that mirror, you are congruent to yourself. All right, when we look at choice 3, and this is what's weird, this used to be the end of our proof. Being able to say that triangle SCT is congruent to triangle TDS is because of side, side, side congruence. I'm not done. I used to be done, but now there's a reason for proving the triangle's congruent. Why do we care if they're congruent? Because if the triangles are congruent, then what I'm looking for is true. If I can prove those triangles congruent, then I can say that corresponding parts of congruent triangles are congruent. And that's going to give me angle SCT is congruent to angle TDS. Carefully look at lines 3 and 4. Same letters, different things I'm talking about. Do you see the difference between the angle and the triangle?
Yeah.
Okay. Can I tell you that I cheat? If they're asking me to prove those angles are congruent, I know that they gave me the points in corresponding order. So when I name my triangle, I'm just gonna copy those because chances are they match up. Are you with me on that idea?
Yeah.
Next one. Angle. GMJ and HMJ are right angles. So here I have my right angles. GMJ and HMJ are right angles. GF is congruent to HF. I got that there. And I know that angle 1 is congruent to angle 2. I've got that story there. Write a paragraph proof to say why angle GJM is here and HJM is here. So these are the ones, oops. These are the ones that I'm proving are congruent. These guys right here. What information that they're given is not necessary? What do you think, Caroline?
When you see a work finger?
Oh, I was gonna use them.
Right angle?
Yeah. Like whether it's a right angle or not, I don't care. Guess why? Do you see the triangles? I was gonna use this side, this angle, and this side are congruent to this side, this angle, and this side. Do you see those triangles? Do I need the right angles? No. Caroline, how are you gonna use those right angles? Were you gonna do something else?
I was gonna say that this top triangle, the top one isosceles and the bottom triangle, that's a shared side. And then there's also a shared side here, so I have sides.
If you can get down to this triangle, because these isosceles angles are just gonna be these smaller angles, not the whole thing. So careful that.
But that base side is sharing a side of the triangle GHJ.
Uh-huh,
So that's a shared side.
yeah. This one here.
Yeah, and you could also do FHM is congruent, like that, or MH is and HM are the same line, and then that would be that, and then there's also a shared side.
Isn't it great?
for
You
MJ.
see her little brain go, whoa, all that geometry. Go ahead.
You could also say, if, since there's a right angle, that is congruent to MH,
Uh-huh,
because they're a midpoint, or M is a midpoint to the line GH.
yeah.
So that's the side, and what the perfect problem.
Yeah, our perpendicular bisector theorem says that if the distance to the two, if the distance to these two endpoints is the same, then this is a perpendicular bisector. So you get these sides congruent. Absolutely. Perpendicular bisector theorem helps you out there too. I love it. So writing a paragraph proof is telling a story. So start with the sentence, we are given And truth be told, if you don't use the given, you don't have to list it. So if I don't wanna say that those are right angles, that's fine, because I can go ahead and get these two angles congruent to each other, because the triangles are congruent through side angle side, and then CPCTC gives me my angles. But however you see it, you go for it, go.
So just because it says like GJM in the angle, that doesn't mean you have to use those three as the triangle that you're working to get the angle.
Yeah, because, just because it's talking about, you mean GMJ.
Yeah.
Yeah, I can prove this without this information, without these red lines, without those right angles. So I can still list it if I want to, but all I really care about is we are given that these two things are congruent to each other, and angle 1 is congruent to angle 2. And then my next sentence is going to be by the reflexive property of congruence. I know that segment FJ is congruent to segment FJ. Now keep in mind, I didn't need to flip-flop FJ and JF because these two triangles are a reflection of each other, and FJ corresponds. My next sentence, by side, angle side congruence, triangle GFJ is congruent to triangle HFJ. And then here's my kicker, here's where I get to bring it home. By corresponding parts of congruent triangles are congruent, that tells me that angle GJM has to be congruent to angle HJM. Because they are corresponding parts of congruent triangles. Go ahead.
When you said reflexive property, is it FJ and FJ again, or is it FJ and JF?
It's FJ and FJ again because there's no rotations happening here. So these two angles correspond and these two angles correspond. So FJ, that relationship wasn't twisted or turned. It's a reflection where it was just folded. So the orientation of the vertice didn't change. Not so bad. Proof of your choice. Bridger, see how this one is twisted?
Yeah.
So when you use your reflexive property here, you will have to say x, y, and yx, right? Proof of your choice. You're being asked to prove, is the distance from wx the same as the distance from z to y? Notice I put question marks on what I'm asking myself because I don't want to misunderstand those markings as congruence. Are you feeling yourself getting in the proof groove?
Yeah.
Your choice if you want to do a flow proof like you do in Delta Math and have it all bleed down. Your choice if you want to draw the chart and do statements and justifications. Corey's already writing his paragraph proof. He's on his way. Your homework tonight is more Delta Math that gives you more practice with CPCTC and the next 2 pages of the packet. True or false, those are the last 2 pages of the packet. Okay. It's last 2 sides. Yeah. So when you come into class next, we're reviewing, and this packet must be finished. Are we good on that?